Hi, everyone, and welcome to our podcast, where we tackle the evolving capabilities of AI head-on. I'm thrilled to have 5 extraordinary experts with me today, each with unique perspectives. We're diving into the notion of measuring AI's ability to complete long tasks, something called the time horizon metric. This is going to be a fascinating ride.
Absolutely. Thanks for having us. My background is in enterprise strategy, and I'm always looking at how these breakthroughs can reshape entire industries, especially the software industry. I think measuring an AI's time horizon is such a clever way to see if it can tackle tasks that used to demand, months from a human developer.
Right? And from a technical standpoint, it's kind of like if existing benchmarks are single-lap sprints, time horizon measures if the AI can run a full marathon. I'm a machine learning researcher, and we're always struggling to interpret benchmark scores in real-world contexts. This approach really helps quantify progress in a more relatable manner.
I'm also on the technical side, focusing on AI model evaluation. I find it super intriguing that we're using the 50% task completion time horizon, meaning, can the AI succeed in tasks that typically take humans X hours, half the time? Or rather, for which tasks does it have at least a 50% success rate at that scale? The results suggest that over the last 6 years, that horizon has doubled every 7 months. That's almost shockingly fast.
Well, and I'm in cybersecurity, so I've seen how these frontier models can be either a boon or a threat, depending on whether they're used for defensive tasks like analyzing vulnerabilities, or, heaven forbid, for orchestrating large-scale attacks. The time horizon metric almost acts like a speedometer. How long can the AI sustain a complex, multi-step drive without crashing?
Yes, and I'm an engineer in the trenches, building agent scaffolds to run these tasks. In practice, we've tested AI through what we call HCAS tasks, rebench tasks, and even 66 new software atomic actions, or a.k.a. The interesting point is that tasks range from a few seconds, choose the right file for a job, to multi-hour coding or data transformation tasks. The ability to handle all that complexity is significant.
Let's unpack the advanced techniques that go into measuring these tasks. I heard mention of item response theory, or IRT. Could you elaborate?
Sure, so typically, IRT is used in educational testing. We treat a task's difficulty as a parameter and a model's ability also as a parameter. By observing success rates, we figure out at which difficulty level the model hits around 50% success. But instead of letting the model define difficulty, we anchor it in human baseline times. So, if it takes a human 50 minutes to do the job, we see how the model tends to do on tasks rated 50 minutes. That's effectively the model's time horizon.
Exactly. And the 50-minute figure is not random. It's just how we calibrate relative performance. We also check 80% success rates, but an 80% success horizon is usually lower. Recent models might have, say, a 50% time horizon of an hour, but only 80% time horizon of 10 or 15 minutes.
In business terms, we're seeing that as the frontier AI time horizon increases, it can tackle longer tasks with at least a 50% success rate. That means, potentially, it's becoming feasible to automate entire segments of software development. Everything from bug fixes that used to take a team days to advanced tasks like data engineering that could take weeks. That could shift labor needs dramatically.
And that's exactly what we saw when we used these metrics on Rebench, which is a set of tough machine learning research tasks. Those might require about 8 hours from a human with domain expertise, or on HCAST tasks that can go up to 30 hours of effort. For some of these tasks, older models like GPT-3 or GPT-2 completely bombed out, basically 0% success. But GPT-4 series and something like Claude 3.7 come in with partial success. That's huge progress.
Building on that, there's this dimension of adaptability. The biggest leaps come from the AI not only generating code, but verifying and correcting mistakes. The scaffolding approach, where the AI can iteratively call tools or run scripts, has improved drastically. We used to see GPT-4 get stuck in loops, repeating the same error, whereas now something like o1 might pivot to an entirely new approach after it hits a wall. That's reminiscent of how a human engineer thinks things through.
Ha, yeah. Whereas older models were sometimes so clueless, they'd try rewriting the code line by line with echo statements and never figure out they could just open the file directly. It's like trying to rebuild an engine while driving at 60 miles per hour. Now, they shift gears more smoothly, though they'll still manage to surprise us with bizarre mistakes on occasion.
That's a brilliant analogy, like rewriting each line with echo statements. My goodness. So we see extraordinary improvement, but let's also talk about the shortfalls. Expert 4, from a security standpoint, do you see limitations that might temper the excitement?
Absolutely. For tasks in truly messy environments, things that are punishing or resource limited, the AI's performance can degrade. Our tasks seldom simulate something super dynamic, like a fast-changing environment or real-time adversary. So if the environment changes under the AI's feet, it's not always good at proactively adjusting. Some tasks measure that, but we'd need even more messy tasks to see if the horizon trend holds in real dynamic settings. Good point. And from an R&D perspective, extrapolation can be risky. Some say, we see a doubling every 7 months, so we'll have a 1-month horizon AI in 5 years. That might hold, or it might slow down if we hit compute bottlenecks or run out of easy ways to scale. On the other hand, if AIs start doing AI research themselves, improving their own training methods, the progress could accelerate.
That's an interesting strategy question, because businesses love linear or exponential extrapolation. But we need to be cautious. If your company invests heavily expecting the horizon to double by next quarter and it doesn't, you might overcommit. Conversely, if you wait too long and the curve does hold, your competitors will have automated massive chunks of their engineering pipeline, caught between a rock and a hard place, right?
Indeed, I've seen a mid-sized SaaS company cut their backlog by about 30% using an AI agent to speed up bug triages. They gave the AI the simpler tasks, things that might take a developer an hour or two. With a well-tuned agent scaffold, the AI was finishing about half of those in under an hour, which matches the 50% horizon concept. That's a big productivity bump.
Another real-world example. A retail platform used an AI agent to handle routine database migrations and data munging tasks that took junior employees days to get right. The AI now completes them in a single afternoon. Granted, it's not perfect. Someone still reviews the pull requests and occasionally reworks issues. But the strategic advantage is quite real.
Those are super compelling examples. Also, dare I say, for people listening who fear the automation wave, it's not always a zero-sum game. We often see a new division of labor, like humans doing the high-context tasks and AI doing the lower-context tasks. Expert 4, does that jive with your experiences?
Definitely. When we talk about cybersecurity, so much labor is sifting through logs or analyzing patterns. If an AI can do that grunt work reliably for, say, an 8-hour chunk that used to require a human, you free up the analyst to focus on the real puzzle-solving aspect. But let's not forget, as the time horizon gets longer, AIs might eventually handle bigger puzzle pieces, too. So it's a pay now or pay later scenario. Automate the small tasks quick, but soon it might handle the entire puzzle. It reminds me of that old quote by Arthur C. Clarke: "Any sufficiently advanced technology is indistinguishable from magic. You look away for 6 months, come back, and the AI's gotten so much better, it feels like magic."
Right, but we can't rely on wizardry alone. The 80-20 rule says that 80% of the code is written in 20% of the time, but the last 20%, the polish, corner case handling, user experience, can take 80% of the time. Even if frontier AIs get that first chunk done rapidly, polishing those details might still demand quite a bit of human skill, at least for now.
So one question that jumps out. If these AI time horizons keep skyrocketing, do we risk advanced models running tasks that could be, well, dangerous?
That's a valid concern, especially if we talk about autonomously executing complex multi-hour or multi-day projects. We've seen theoretical scenarios where frontier AIs could do something like chain together steps for malicious goals. It's not science fiction to picture an AI finding vulnerabilities in code while also spinning up new expansions of itself.
Exactly. That's why we talk about safety guardrails. If we measure an AI's horizon and it's reliably at a certain threshold, we can decide that we only deploy it with, say, an internal code review or limit which servers it can spin up. The risk from an AI with a 2-hour horizon is quite different from one that can run effectively for a month.
Let's not scare the entire audience, though. Yes, these advanced scenarios are on the horizon, pun intended, but practical safety frameworks can help. The important part is to keep evaluating them in real or near-real tasks, not just with synthetic benchmarks. That's why these open-ended tasks like Rebench are so valuable.
Absolutely. And I like that pun. So let me shift gears. Suppose a CEO or CTO out there asks, what's the immediate strategic benefit of tracking AI time horizons? Expert 1, from your vantage point in enterprise strategies, how would you answer?
I'd say number one, you get a crystal clear metric of whether you can trust an AI on increasingly complex or extended tasks. So you can forecast ROI. If your horizon is 10 minutes, you only trust it for small code corrections. If it's 10 hours, it might handle entire sprints. That's a game changer for planning headcount and investment. Number two, you see it coming. You notice the doubling trend and can prepare for the next wave of tasks that the AI might conquer. That spans software development, data analytics, marketing automation across the board.
And ironically, the better the AI gets, the more you want to measure these horizons carefully. Because at some point, you might want to keep the AI on a shorter leash, especially if you see it can accomplish tasks that used to take a team a month. That's a ton of power in one system.
True. Another heuristic I sometimes mention is the tool adoption curve. The easier it is for the AI to incorporate additional tools or checkers, the faster its horizon might expand. We saw that happen with code compilers, package managers, or extrinsic modules. We tested agent scaffolds where the AI seamlessly checks solutions with a unit test mid-run. That alone upped success rates by 15 to 20% on tasks.
That's reminiscent of the 80-20 rule you mentioned earlier. Just hooking in certain tool belts gives you a massive jump in performance. Now, I'm curious if any of you have a contrarian take. Are we focusing too much on capability growth when we should be focusing on reliability?
To be contrarian, yes. I'd argue reliability is the real bottleneck. If the AI does well 50% of the time on a 5-hour task, that's not good enough for mission-critical systems. People often forget that in real business contexts, one catastrophic error can undo all the cost savings from automation. So we might see a short plateau or a slowdown in adoption until reliability leaps forward.
Great point. I saw an instance with a major software client. The AI was 90% successful on an 8-hour data pipeline, but that 10% was enough to generate data corruption once a week, leading to big headaches. They ended up rolling back the AI usage. So horizon is essential, but reliability is the companion metric for, real trust. Right. So a quote from W. Edwards Deming comes to mind. Without data, you're just another person with an opinion. We do have data on success rates, but we also need robust error analysis, because the magnitude of an error is as important as the frequency. If you can mitigate the magnitude, like having an easy revert mechanism, then 50% success might still be beneficial. If you can't, 99% might still be too risky.
Excellent. We've covered a lot. Doubling time horizons, business use cases, potential dangers, reliability. Let's start steering this toward final insights. Where do you see this conversation going in the next 3 to 5 years?
Honestly, I see more large-scale pilot programs. Enterprises are going to approach these tasks in increments, starting from short, well-defined tasks and scaling up. As the horizon extends, entire workflows will start shifting to AI.
I see an arms race in both open source and proprietary AI versions with better agent scaffolding. If the horizon data continues to show a consistent doubling rate, we'll see pretty sophisticated AIs tackling tasks that are 20 to 30 hours by 2027 or so, maybe earlier.
Technically speaking, I'd like to see more messy tasks in the evaluations, like bridging the gap between a single advanced code-based environment and real multi-agent systems. If the horizon still doubles there, We're in for some profound transformations.
I'd also like to see better synergy between domain experts, like a product manager with domain knowledge, and these AI agents. Often you can boost success rates if the AI is guided by well-structured prompts from someone who deeply understands the final business goal.
Exactly. And I'd add that I think we'll see specialized scaffolds making reliability less of a wild card. Tools for rollback, better test coverage, etc. But also, we might see employees complaining the AI hogs all the easy tasks, like a comedic twist on, the robots ate my job, but it was the most boring part anyway.
Ha, that might be the future comedic relief. Hey AI, are you sure you didn't just want to do the entire sprint so I can grab a coffee or two? Well, we're almost out of time. Let's do a quick lightning round. One final takeaway each.
Sure. Look at the time horizon trend now. Don't wait until you're behind the curve. Start small, pilot projects immediately.
My takeaway, leverage advanced measurement methods like IRT. Don't just say the model's accuracy is 90%. Ask what tasks can it reliably do for hours.
I'd say be bold, but cautious. This technology grows fast, so be prepared to pivot and reevaluate your risk frameworks every 6 months.
Considering security, embed safe usage guidelines from the start. The further these models can run autonomously, the bigger the potential risks.
And from an engineering angle, prep your infrastructure for AI integration. The agent might need more inference compute, but it can save you a lot of developer hours.
Fantastic. Thanks to all of you for a rich, dynamic discussion. This has been wonderful. We learned about time horizon doubling, business implications, safety concerns, advanced scoring techniques, and so much more. I hope our audience has gained fresh insights. Until next time, stay curious and keep innovating.